So the topic was given to me a little while ago, looking at management options in light of the kinds of things that you just heard. And we just released a report on Thursday that I think is a good way of kind of looking at this. What we did was look at what happens if the drought continues for another 2-3 years, the same kind of conditions that we've had in 2014 in particular when we picked the hydrology. And this is work that was done in collaboration with a number of colleagues and interdisciplinary teams. Let me just shout out to them quickly. Jeff Mount, who's a hydrogeomorphologist and rivers guy, Caitlin Chappelle, who's a public policy and biologist expert, Jay Lund, who's an environmental engineer, Jose Medina Zuara from Jay and Jose and Peter Moyle, all from UC Davis. Jose is an economist. Peter Moyle is a fish biologist. And then Nat Phoebe, who is with Point Blue Conservation Science, who is an expert on water birds. And we really wanted to have this team to kind of be able to look at the range of different things going on. And the way we did the work was by pulling together as much data as possible, but then also conversations with a lot of folks in state, local agencies, stakeholder groups, federal agencies. So just to start off, and this is, you've seen different versions of different of these phenomena, but I think it's actually useful for thinking about how bad things are so far in this drought. So we're 4 years in now, and what this chart shows you is average precipitation, or the orange bars, and then the squiggly line up there is reservoir levels in the California-based reservoirs, our major reservoirs. And what is interesting, I think, is to see that we actually started out with pretty full reservoirs, because 2010-11, the year that you saw in some of the graphs that I think especially Peter showed, was really wet. So they were full. Because when we do get a big storm, our surface reservoirs can tend to fill up pretty quickly. That's true for our groundwater basins. And so in the beginning of the drought, nobody really kind of felt like it was a drought, because they were able to, at least in terms of water users, they were able to tap some of the extra water that was stored in surface reservoirs. That is no longer the case. Now we're basically relying on kind of what we get every year in terms of surface water, and then on tapping our groundwater reserves, which I'll show you. I'll talk a little bit more about that in the beginning. Later on, the blue line there just shows you that was the average. That was the lowest point of reservoirs back in November of 1977. That was when operating rules were a little bit different. We weren't as worried about keeping some water there for winter run salmon and other critters who need water released below the dam. So also you've heard, and this is just a way of teeing off the sort of theme of why I thought this talk would be useful at this conference, it's been hot. And the combination, as Noah showed really well, combined hot and dry, and it's really much worse and much harder to manage. So we talk about this as a drought of the future, in the sense that this is the kind of drought that the climate models have been anticipating we're going to have to deal with in 2050. Peter presciently noticed that already back in the late 80s. The snowpack this year was lower than the snowpack projected in some of the models for late 21st century. So we're looking at the kind of drought that we have to get more and more ready for. And I think that's a really important message that we're trying to convey in terms of thinking about adaptation strategies. In some ways, it's lucky to have this opportunity to start to think about this, because we're going to have to deal with this more and more. And I'll talk about in particular where this matters the most, in fact, is with respect to ecosystem management, where you can't just pump groundwater to make up for lost surface water. So just also a quick slide to show you, there's been the drought emergency was officially declared in January of 2014, almost immediately. Additional funding went into this at the state level. The feds have also provided some funding. This breaks it down. These are allocations at this point into basically different kinds of emergency assistance, emergency funding for impacted communities, for safe drinking water in rural communities, for some ecosystem support, wildfire management, and then also on the state side in particular, a huge chunk of change for water system investments that are not really expected to work tomorrow or next month. It takes a while to get some of that money out the door, but the aim is to accelerate spending on the kinds of things that Peter mentioned in terms of diversifying supply portfolios, in terms of reducing demand that can if the drought lasts a long time, can definitely help for this drought, but also will help us with future droughts. So, a little bit, just a quick overview of what I'm going to talk through. What if the drought continues? I'll tell you a little bit about the scenarios there, and then focus on the 4 areas of concern that we looked at, which is cities and suburbs, farms, rural communities, and the ecosystem, and then a bit on some of the management options for building drought resilience. So, talked about El Nino. Here's the shotgun blast of El Nino years versus rainfall, and the orange dots are in the El Nino years, and the y-axis is precipitation. So yeah, a really big El Nino year has, in a couple of cases, been associated with lots of rain, but it's not a guarantee. So I don't know if I'm terrible at the stock market, so I wouldn't want to bet anyway. But whatever I bet would go the wrong way. So maybe I should bet on it being dry. But it's an unreliable predictor, and so let's not just, sit with our hands folded and expect that things are all going to be fine this winter. Also, it's important to think that even a pretty wet year, it could fill up our surface reservoirs, but it's unlikely to undo all of the other consequences of drought so far. And it's really important to think about what kind of impacts we've had so far, how we're doing, and what kind of impacts are likely to think about actions we might be able to take in the near term to reduce harm, as well as in terms of thinking about how do we get better at preparing for next time. So what we looked at was just a repeat of 2014 hot and dry conditions for another couple of years, and there's a sort of summary of these impacts in the report. It's in a table if you want to sort of see them and use it for any purposes. But basically, we're looking at pretty dry, reduced runoff. We've been experiencing now already 25 to 40% of average. Kind of depends on which watershed. Storage, surface storage, about half of average. Surface water cuts for farms on the order of about half of what farms usually get in terms of surface water. And for cities, a sizable chunk as well, 2 to 2.5 million acre feet. Extensive curtailments of water rights. That's been happening for the first time in a formal way in a very long time, and it is likely to be increasing. This is when the state board orders people to stop diverting. Extra groundwater pumping. This is basically how farms have been making up for the lost surface water. Not 100% make up, but quite a bit. This is all from the latest UC data study that Noah highlighted. Some of the authors are overlapping between the two reports. So definitely some consequences we're going to see there. Reduced hydropower. Peter mentioned it's about half of the sort of recent average. Raising electricity costs about 2%. I will say one thing in terms of the hydro that's lucky for us relative to the 60s when we were about 30% or more dependent on hydro. That dependency has gone down. There's hope that the new renewables will help to offset some of the kinds of things that Peter raised, but it's kind of early to tell, right, in terms of the greenhouse gas impacts and the feedback loops. Decreased water quality, that's a big one. And when we think of water quality, we often just think of pollution, but in this context, it's temperature and it's salt, as well as various kinds of different chemical things. The temperature is really key for ecosystem management, in fact. Okay, so let's look through 4 areas of concern. We ordered these in order of doing okay to doing terrible. So I'm going to walk you through the sort of the good news and then get to the bad news progressively as we go through this. So the good news is that actually cities and suburbs are doing pretty well. And if you consider how much they've been cut in terms of water supply. And this is thanks to the fact that it's not the first drought we've had, and we've made a lot of progress in building drought resilience in our urban and suburban communities, and that's especially thanks to the drought that lasted from 87 to 92, when I think a lot of urban communities found that they were really scared and running quite short, and so there have been tremendous investments in all kinds of things, ranging from managing demand, building local storage, underground storage. Metropolitan Water District of Southern California has increased storage by a factor of 13 or 14-fold since the early 90s. A lot of that's underground. Conservation, for sure. Regional cooperation. This has been an interesting thing that's kind of happened quietly in many different parts of the state, where urban agencies just started interconnecting their systems, starting in the early 90s, and this has been amped up even more since the drought has come in. What it means is, say, a place like Folsom, which is very vulnerable to Folsom reservoir levels, is now able to be connected to the groundwater resources within the wider region. Those kinds of things are happening in many different parts of the state and make a big difference. So, continued drought. What are we expecting? Supplies are definitely going to be tighter. There's going to be more belt tightening. We foresee some challenges for urban utilities because they are losing money. When people are successful at conserving, that tends to affect the bottom line of utilities, in part because they don't have pricing structures that are well adapted to that, in part also just because 70 to 80% of utility costs are fixed, and so it's kind of hard to both simultaneously send a price signal to people based on the volume they consume and manage your finances. And there are some constitutional challenges that utilities now face in using some of the most aggressive kinds of conservation-oriented pricing. There are also some threats to affordability for low-income folks. Challenges in some respects with the conservation mandate, and we're sort of suggesting that if the drought continues and there's a desire to go beyond the 25% statewide mandate, to think about that somewhat flexibly, both in relation to local supplies, but also in relation to the amount of commercial and industrial use there is in different communities. But overall, economic impact for cities and suburbs, which is where most people live and where most of the economic activity of the state is, about 98% of the state's GDP, 95% of the population, those impacts are likely to be small, and that's in part thanks to this progress in water management and in part thanks to the fact that we're not very water sensitive in terms of our economy, by and large. Now that is less true for farms. Farms obviously are an important water user in California. They use about 4 times as much as cities and suburbs combined. It's the nature of California agriculture. It's a great place to grow things if you can add water during the dry growing season. You can actually be much more precise about how you grow it. You're not going to get ruined by rains coming at the wrong time and all that, but it does mean that you need to add the water to make it work. Now, I told you about the cuts that they have had to their water supply with the drought, and about half of their surface water this year, which equals about a third of annual water use in agriculture in California. Groundwater pumping and water trading have largely been able to reduce those losses. So with continued drought, we expect in some ways more of the same. And this is, the new study from UC Davis really kind of highlights these are just some extracting some of those numbers. For about half of the 50% surface water cuts, fallowing of about 6% of acreage, about 4% decline in ag revenues relative to the cost, and jobs about 6%, farm jobs, but state GDP less than 0.1% impact. Now, there is a downside to this, and that's that pumping is accelerating subsidence. Some new numbers came out about that earlier last week. So this is going to be a management challenge, especially in specific places. Rural communities, now we're moving down the sort of not adapting as well, and this is, these are both folks who are impacted by the kinds of job losses in agriculture that I mentioned, but also facing, many of them rely on shallow wells, either domestic wells or small systems, and this has been in the news some, it's basically the problem of these wells going dry, and a lot of these folks are not in a position to deal with it quickly on their own because of the financial means are not there, and it's just hard to get a well driller at this point. So the state has recognized this and put a lot of resources into trying to coordinate and get response there, and has done a lot. But what we found is that the timelines for response are still too long, and there's still too much bureaucracy to make this happen fast. And it's also stopgap solutions. It's explicitly temporary solutions for the domestic wells, and those wells are not likely to fill up anytime soon. So with continued drought, we're saying that those programs have to be amped up. This is also an area where we're going to be expecting some worse public health impacts with worsening air quality, particularly in the San Joaquin Valley. Okay, now to ecosystems and the worst news. And this is news that is starting to get covered now, but it's not been as much in the spotlight, I think. And this is where we're really being hit hardest by this combination of drought plus heat. So record low flows combined with high temperatures has just made it very hard in a lot of ecosystems what we're seeing is, in forests, increased wildfire risk of a really unprecedented scale as trees are dying off with underlying difficult conditions in our forests because they're already too dense. We're seeing a lot of problems with our native fish, amphibians, and reptiles, as well as with water birds. The state agencies have basically been doing stopgap measures for fish with rescues and monitoring. We've seen some positive innovations in water bird management to really try to coordinate and use the water in our wildlife refuges and on farms in as precise a way as possible to avoid die-off. But with a continued drought, what we're looking at are some really, really difficult things. And in particular, we did some work drawing on Peter Moyle's work on climate change impacts of fish to look at which of our fish species are most vulnerable right now in the near term to extinction. 18 out of 121 native fish species that we have still in California. That includes most ones of salmon, a number of trout species, as well as a variety of other fish. And you can see from that map, they're kind of all over the state. They're not just in the Delta. So water bird mortality has been avoided so far, in part thanks to management, in part thanks to some lucky timing of rains. But there's a big risk for major die-off of the birds of the Pacific Flyway as well. In both of those cases, money can help in the near term by helping to support getting money into some strategic places, strategic watersheds and wetlands. In addition, for fish, we're likely to need conservation hatcheries, which are hatcheries that basically kind of like zoos that keep the biodiversity if conditions in the wild get too bad in the near term. Wildfire risks, we're likely to see more rimfire type events, and there's not much to do about that except just kind of CAL FIRE's current strategy, which is to try to keep keep small fires from getting too big. So quickly running through building drought resilience, we looked at what's working, what's work in progress, and difficult work ahead. So what's working are the diversified water portfolios, regional infrastructure development, involving often now cities and farms together. Coordinated emergency response has helped a lot. Work in progress, kind of a list of things, a lot of them I mentioned already that need to get better. There are already some good things happening, but they need to get better. Groundwater management, I'll just call out that we did pass a historic act in September of last year for sustainable groundwater management that charts the way forward in terms of longer term drought resilience for California's agriculture. It's going to take a little while to implement, but anything the state and the feds can do to help that by doing things like paying for farmers to get meters on their wells so that they're ready to be able to get involved in management locally will help. And then water bird management, the example I'll just throw out there is paying farmers to flood their fields at strategic times. That's a really positive thing that has worked both through a Nature Conservancy program and through some federal programs. Difficult work ahead is just a list. A lot of the kind of things that Peter mentioned in his last slide as well in terms of improving our information system, improving the functioning of our water rights system. The curtailment process has been bumpy. Managing trade-offs in clearer ways. I mentioned some of the avoiding extinction part, and then just we're thinking about the long-term, how do we get better for managing droughts like this in the future with respect to our ecosystems? It's really about rebuilding resilience. Our native ecosystems were adapted to drought, and we've kind of unadapted them by the way we've managed land and water. So there's really some work to be done there in order to get better. And then I'll leave you with a pretty picture of clouds. Not to say that El Nino would be a bad thing if it does rain, but worried about floods too. Thank you.